Hi everyone, Assalamualaikum. In this video, we are going to discuss how to determine whether the limit is exists or does not exist. First, we look at two-sided limits. Limit x approaches a from the left fx. Okay? This sign we read as limit from the left, right? And then limit x approaches a from the right fx. This sign we read as from the right. Right? Now we look at the theorem or the condition for the existence of a limit. If limit x approaches a from the left fx equals to L and limit x approaches a from the right fx equals to L, then limit x approaches a, no right or left here, fx equals to L, right? Means the limit is exists, right? If limit x approaches a from the left fx not equals to limit x approaches a from the right fx, then limit x approaches a, no right or left here, fx does not exist, right? We look at example 1 where fx is a single function. Given fx equals to x squared minus 9 over x minus 3. Determine whether limit x approaches 3fx exists or does not exist, right? From the given question here, we have limit x approaches 3fx, right? So, to determine whether limit x approaches 3fx exists or does not exist, we have 4 steps, right? Step 1, we need to find limit x approaches 3 from the left fx, okay? We find limit x approaches 3 from the left here because we want to determine whether limit x approaches 3fx exists or does not exist, right? And then step 2, we need to find limit x approaches 3 from the right fx, okay? From step 1, we need to find limit x approaches 3 from the left fx, okay? In step 2, we need to find limit x approaches 3 from the right fx, right? And then step 3, we need to check whether the value of limit x approaches 3 from the left fx equals to limit x approaches 3 from the right fx. Alright? And then step 4, we can conclude whether limit x approaches 3fx exists or does not exist. Right? Under step 1, to find limit x approaches 3 from the left fx, first we need to replace fx equals to x squared minus 9 over x minus 3. Right? Right, how to find limit x approaches 3 from the left? Okay, negative here is not negative 3. Okay, but it means from the left. Okay. So, if we use direct substitution, we need to replace x equals to 3, not equals to negative 3. Okay, let's say we use direct substitution. So, we just plugging 3 into variable x here. So, we get 3 squared equals to 9, and then 9 minus 9 equals to 0. And then we replace 3 here, so we get 3 minus 3, which is also equals to 0. So, after we use direct substitution, we get 0 over 0, which is indeterminate form. So, in this case, we cannot use direct substitution to find limit x approaches 3 from the left, right? So, what should we do? Okay, if the function here is in quadratic function, we need to factorize, right? So from here, we have limit x approaches 3 from the left, and then after we factorize x squared minus 9, we get x plus 3 times x minus 3, and then over x minus 3, right? And then we can simplify x minus 3 in numerator and x minus 3 in denominator, right? After that, we get limit x approaches 3 from the left, x plus 3. And then from here, we can solve using direct substitution. Okay, we just plug in 3 into whatever x here and then plus 3. Okay, and remember, after we use direct substitution, no more limit expression, right? And then we solve 3 plus 3 equals to 6. Right, so limit x approaches 3 from the left fx equals to 6. Right? Right, under step 2, we need to find limit x approaches 3 from the right fx. Right? So to find limit x approaches 3 from the right fx, since we have single function here, okay, so we still use the same fx, okay, limit x approaches 3 from the right, fx equals to limit x approaches 3 from the right, x squared minus 9 over x minus 3. Since we have the same function, so the solution is exactly like this, right? Right, so from here, after we factorize, so we get this, and then we can simplify x minus 3 in numerator and x minus 3 in denominator, and then we get this, okay? But under solution here, we have limit x approaches 3 from the right. Okay, this is limit x approaches 3 from the left. Okay, and then until here, we can use direct substitution. Okay, we replace x equals to 3. Okay, to find limit x approaches 3 from the left, we replace x equals to 3, not negative 3. Okay, and then to find limit x approaches 3 from the right, we also use the same value, okay, which is positive 3 here. Okay, so of course we will get the same value because we use the same fx. Okay, so the answer equals to 6. Okay, limit x approaches 3 from the right, fx equals to 6. Right? Right, we have same value when we find limit x approaches 3 from the left fx and limit x approaches 3 from the right fx. Why? Because we use the same fx since fx is given in a single function, right? Now we continue with step 3. Check whether limit x approaches 3 fx equals to limit x approaches 3 from the right fx. Okay, from here, we can see that limit x approaches 3 from the left fx equals to limit x approaches 3 from the right fx, which is equals to 6. Right? Then we can continue with step 4. We can conclude whether limit x approaches 3 fx exists or does not exist. Right? So we can write limit x approaches 3 fx equals to 6. Okay, since limit from the left equals to limit from the right equals to 6. Okay, so we can see that limit x approaches 3 fx equals to 6, which is exists. Okay, we need to write this word. Okay, and then look at the syntax here. Okay, from here we have 3 and then from the left, and then here 3 from the right. But when we conclude whether the limit is exists or does not exist, we just put 3 here, no right or left symbol, right? Got it? We look at example 2, piecewise function. A piecewise function is a function where more than one formula is used to define the output over different pieces of the domain, right? Given gx equals to piecewise function x squared minus 9 over x minus 3 for domain x not equals to 3 and gx equals to 4 for domain x equals to 3. Determine whether limit x approaches 3 gx exists or does not exist. Alright, from here we have limit x approaches 3 gx. Okay, to determine whether limit is exists or does not exist, there are 4 steps. Okay, step 1. Find limit x approaches 3 from the left gx. We use gx here because the given function is gx. If the given function is fx, so we need to use fx symbol here, right? And then we use limit x approaches 3 here from the left because we want to find limit x approaches 3 gx here, right? Right, step 2. Find limit x approaches 3 from the right gx. Step 3. Check whether limit x approaches 3 from the left gx equals to limit x approaches 3 from the right gx. And final step, we can conclude whether the limit exists or does not exist, right? To find limit x approaches 3 from the left gx, we need to consider the domain. Okay? For domain x not equals to 3, we can draw a real number line notation. Right? X not equals to 3 means when x equals to 3, we have whole here. Okay? And then for domain x equals to 3, from real number line notation, when x equals to 3, we can put a dot here. Okay. For domain x not equals to 3, this arrow we use to find limit x approaches 3 from the left. And this arrow we use to find limit x approaches 3 from the right. Right? And then from domain x equals to 3 here, there is only dot here. No arrow from the left and no arrow from the right. So in this case, we not use this domain. Or in other words, we not use this function. Right? Alright, now we look at step 1. Find limit x approaches 3 from the left gx. Okay? As I said before, to find limit x approaches 3 from the left gx, we use this arrow. Means that we use this function. Right? So, limit x approaches 3 from the left gx equals to, we replace gx equals to x squared minus 9 over x minus 3. Okay, let's say if we use direct substitution, we plug in 3 into variable x here. Remember, we replace positive 3, not negative 3, because minus here means from the left, not negative value, right? So in this case, let's say we use direct substitution. After we replace x equals to 3 into x here, so we get 0 over 0, which is indeterminate. So in this case, we cannot use direct substitution to solve this limit. Okay? And then from here, we have quadratic function. So we need to factorize, right? So after we factorize this quadratic function, we get x plus 3 times x minus 3. Okay? And then we have same factor from numerator and denominator here, so we can cancel it, right? Then we have limit x approaches 3 from the left, x plus 3. And from here, we can use direct substitution. And after we use direct substitution, no more limit expression. We plug in 3 into variable x here, so we get 3 plus 3. And the answer equals to 6. Okay, so limit x approaches 3 from the left gx equals to 6. Right? Then we go to step 2. Find limit x approaches 3 from the right gx. Okay, from here, when the domain x not equals to 3, we have arrow from the right here. Means that To find limit x from the right, gx, we use this arrow. Okay, this arrow means for this domain and this domain means for this function. So in this case, we use the same function from the left and from the right. Okay, limit x approaches 3 from the right gx equals to limit x approaches 3 from the right x squared minus 9 over x minus 3. We use the same function because the arrow from the left and from the right comes from the same domain and come from the same function. Okay, and if we use the same function, so of course we get the same technique. Okay, we use the same technique and then the final answer of course equals to 6, right? So from here, after we cancel this, we have limit x approaches 3 from the right gx and then equals to 3 plus 3 equals to 6. Okay, but the symbol here is limit x approaches 3 from the right. Okay, and the symbol here is limit x approaches 3 from the left, right? Right, then we go to step 3. Check whether limit x approaches 3 from the left gx equals to limit x approaches 3 from the right gx. So from here, we have limit x approaches 3 from the left gx and limit x approaches 3 from the right gx equals to 6. Right? So we can write limit x approaches 3 from the left gx equals to limit x approaches 3 from the right gx, which is equals to 6. Alright? After that, we continue with step 4. We can conclude whether limit x approaches 3 gx exists or does not exist. So we can write limit x approaches 3 gx equals to 6. Okay, means that exists. Okay, we need to write this word. Alright, and then from syntax here, from here we have limit x approaches 3 from the left, and this is limit x approaches 3 from the right. But the final conclusion, we only write 3 here. Okay, means limit x approaches 3 gx exists. And the value of the limit equals to 6. Right? Got it? Coming up next, two-sided limits. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.